Hello, Hopewell. This is Mr. Steinberg. Today's lesson is 8.6. It is on classifying and translating conic sections. There are two very short sections of videos for you to watch, and then some practice on a Google form. Let's get started with section 1. So the directions say classify each conic section. What we have here at the top of this page is all of these equations are what we call the standard form equation for conic sections. Your standard form equations have your factors as binomial squares. They're not multiplied out as perfect square trinomials, and they're written in such a way that you can identify your conic section just because of the characteristics of them. The four conic sections we have to choose from are the parabola, the circle, the ellipse, and the hyperbola. Each equation has a different feature, and let's get started by identifying which of the top 8 are parabolas. Parabolas have one variable that's to the second power, and only one variable that's raised to the second power. So when I go through the first 4, let's say, when I see both x and y squared, I know that these are not parabolas. If I have a y term that's squared and not both x and y, that is a dead ringer. That is a parabola. And that's what we're doing in this top section. Let's see if we can identify any other equations that are parabolas. I believe there are a few more. What do you think about exercise number 5 and exercise number 7? Both of these represent parabolas. They're parabolas because only one quantity or variable is raised to a second power and the other one is not. The x is being squared and not the y. This parabola will open upwards or downwards, but we know it's opening up because of what we've learned all throughout the year. This parabola will open to the right. If we have like a 4py equals x squared or 4px equals y squared, that determines which direction it opens. This would be x plus 2 if I wrote this out in a different way. This would more closely resemble the standard form that I've taught you, where this has an invisible 1 out in front, and this would represent the value of 4 times p. So we know that this is a parabola. Next, I'd like to identify the circles. Circles have both an x and a y squared term, and the signs of both of the x squared and the y squared terms are both the same, either both positive or both negative, which means the x squared and y squared, we're going to look for them to be added together. One other thing, we've learned also that the equation for an ellipse has both an x squared added to a y squared. So differentiate an ellipse and a circle by looking at the coefficients of the ellipse and the circle's x squared and y squared terms. For example, this is what I mean. Question number 1 has an x squared and a y squared. The coefficient of each, the x squared and the y squared, is 1. They are equal. Same can be said for number 2. The x squared and the y squared coefficients are both 1. They are equal. Number 3, the coefficients of the x squared and the y squared are not equal. 1/9 and 1/16 means that number 3 represents the equation for an ellipse. Questions 1 and 2 represent equations for circles. Number 6 is very different because we have a y squared and an x squared with a minus in between them. This can't represent a circle, and it cannot also represent an ellipse for that reason. Number 8, however, has an x squared term and a y squared term separated with a plus. Are their coefficients the same? The coefficient in front of the x term is 1. The coefficient in front of the y squared term is 1 over 25. Being that these are different coefficients from each other, the y squared and the x squared are added together terms. Those terms are added together. That would make number 8 an ellipse. The reason number 6 is our last conic section that we learned about, a hyperbola, is that we have both an x squared and a y squared term but they have different signs. The y squared is positive and the x squared is negative, meaning that this will form a shape that's a hyperbola, and the hyperbola will open up and down because the y value, or the y variable, is the positive squared term, and the x is the negative squared term. So these are a few ways to identify your conic sections when they are written in the standard form, and all of these equations resemble standard form, especially if we edit things like number 5, and again if we edit this one, number 7, this is more closely resembling the standard form equation for a parabola, 4py equals x squared. So if we move that 3 over and factor out a greatest common factor, which would have been a 1, that 1 represents the value of 4 times p. Please continue to our next video.